Now let's work on solving a problem with deflection. Here is, this is the beam that we're going to look at in the quiz you're doing. And as you can see, it's a simply supported beam, one support at each end. It's got a distributed load, and they tell us about the dead load. The dead load, distributed load, little d, is 300 pounds per foot. The live load is an additional 400 pounds per foot. So let's work our way through step by step. We want to convert any foot things into inches so that we have all our numbers in the same kind of units. So first, let's convert the length to inches. And if this is 16 feet, how many inches is that? Well, what is 16 times 12? 16 times 12 will give you how many inches this length is. Now we'll think about this live load here. It says 400 pounds per foot. And when you're thinking that we're going to convert this to pounds per inch, first just ask yourself, what would be reasonable? Am I going to look for, is the pounds per inch going to be a bigger number or a smaller number? And I like to picture a chunk of wood 1 foot long with a load on it, and then I picture a little tiny chunk of wood with a load on it, and I think, okay, which one's going to have a heavier load? Aha! The short little 1-inch length is going to have less weight sitting on it than the big old 1 foot length. So that kind of orients me what direction to go as I'm using 12 inches per foot to do things. So what I'm going to do is take my 400 pounds per foot and divide it by 12, because there are 12 inches per foot. And if you're a unit analysis sort of person, the per foots cancel out. And there we are, look, 400 pounds per 12 inches. What's 400 divided by 12? 33 1/3 pounds per inch. So the live load in inches is 33 1/3 pounds per inch. Okay, now let's look up one of the numbers we're going to need, the moment of inertia. And remember that moment of inertia is stiffness of a shape. So we're going to look that up in our lumber table. It looks like this. You have this in a handout. You've gotten this one before, I think, but here it is again in a handout. This is the properties of wood timbers. And we're looking for, our beam that we're working on is 8 by 16, so it's down here 2/3 of the way down. I have used our friend Photoshop and zoomed in on that part of the table in the next slide here. So here I'm zooming in on that part of the table. There is our 8 by 16 timber, and let's go across, let's look at the heading. Here are all the various properties. Here's the one we want, moment of inertia, There's the moment of inertia for our 8 by 16 beam, 2327.42. So now we can start to answer the question, how much does this beam deflect due just to the live load alone? And to find our formula we're going to use, let's look at this handout that we have. This handout shows you pictures of different load conditions and tells you what formula to use for the particular situation you have. And you have a simply supported beam with a distributed load, as we see in this picture. So we're going to use this formula here. And we now know a bunch of things. We figured out how much is the distributed live load per inch. We figured out how long is the beam in inches. We were already given the modulus of elasticity. Remember, that's stiffness of the material. And we just looked up moment of inertia. Remember, that's stiffness of a shape. So now we can plug all those numbers into this formula we just got from the table. And we don't have to worry about why are these things here. Just trust that this formula will do it for you. And we'll just plug in the numbers. So to find the maximum deflection on this beam, we'll just plug in the numbers. There's the 5. Here's the distributed load, W, in pounds per inch, 33 1/3. Here's the length in inches, 192. And according to this, we go that to the 4th. Then that's divided by 384. There's 384. There's the modulus of elasticity right there. There's the moment of inertia, 2327.42. We just plugged all those numbers in. Now, I get a little bit obsessive about putting parentheses into my calculator. You might have a different approach. You might feel more comfortable with order of operations than I do. I always worry that I'm going to, get them scrambled up. So I just parentheses the heck out of them. So I've got the whole term up here on the top with a set of parentheses around it. And then I've got a whole term on the bottom with a set of parentheses around it, and then other parentheses inside. So if that makes you comfortable too, feel free to do it. Other people like to just figure out what is this top one and write it on a piece of paper, or store it in your calculator's memory if you have that function. Now let's think about how much does it deflect due to the dead load. And that was 300 pounds per foot. And what is dead load? Remember, that is just the weight of the structure itself. So 300 pounds per foot divided by 12, the per foots can go away, and we've got 300 divided by 12 tells us each little inch is going to be carrying 25 pounds per inch. 300 divided by 12 is 25. So that's what the dead load is in weight per inch. Now, what is the total? Because we're being asked to figure out how much is the total with the dead load and the live load together. So we figured out the live load, 400 divided by 12 gave us 33 1/3 pounds per inch. And we figured out that the dead load, 300 divided by 12 gave us 25 pounds per inch. So altogether, those two add up to 58 1/3 pounds per inch total distributed load. Each inch of this beam is carrying that much. So now, ta-da! How much does the beam deflect with the dead load, the weight of the beam, and the live load, this distributed load, all together? And we now know the distributed load for both dead and live load is 58 1/3 pounds per inch. We previously figured out that the length is 192 inches. We were told the modulus of elasticity, the stiffness of the material, and we just looked up the moment of inertia. So let's plug all that stuff into our same deflection formula that we got off of that table. So here's the deflection formula if you have a distributed load. And now let's just plug in those numbers. There's the 5 again. There's the distributed load altogether, 58 1/3. There's the length in inches, 192 to the 4th. And I've put all that in parentheses because I'm more comfortable doing that. Then on the bottom of the fraction, we got the 384, we got the modulus of elasticity, and we've got the moment of inertia that we looked up. And there, you'll come out with a number, I forget what it is, but it's in your quiz solutions. So there's the end of this quiz.